In the last video, I developed a model that we can use to demonstrate lifetime estimation using MechDesigner. The model has conjugate cams driving a trapdoor to drop tubes onto a flighted conveyor. Before we move on to the lifetime estimation, I just need to talk a little bit about the Conjugate Cam Function block. This function block is required if you're going to have a conjugate cam, just a little bit of explanation now about what it does. The conjugate cam function ensures that load is only ever applied to one of the cams specified in the cam list at any time in the machine cycle to avoid a static indeterminacy. As the load switches direction, one cam will begin to be stressed while the other cam's stress will become zero. In reality, provided a cam has been designed and manufactured correctly, there will occasionally be a relatively small load on the passive cam flank because of the anti-backlash preload usually applied to the rollers. The blue areas on the cam profile represent zero stress, so we can see that the pressure switches from one cam to the other at an instant in time. Okay, so after that brief explanation on the conjugate cam function block, we can return to the lifetime estimation. We can access this by opening the cam track dialog by double-clicking on the cam in question. Okay, so once the dialog is visible, we can turn on lifetime calculations by entering the parameters tab and then clicking on the enable lifetime drop down. And there are two options here. Well, there are two boxes here. One show roller and cam lifetimes, and the safety factor. I'll talk about the safety factor a little bit later, but first you just click this checkbox here and you'll notice that two tabs appear, the roller life and the cam life. So the first thing we'll talk about is the roller life. So I go into the roller life tab and we're presented with this information. The first thing to do is select the roller itself that we want to use. So we can select a roller from the database or databases, and we have several databases. There's ENA, COYO, NSK, SKF and THK. In this case I've selected the ENA database and I've gone for a KR16. But what you have to, what happens though if I choose a different one, say a KR22, if you look at the roller here, which is the one, this is the cam that we're investigating, this one. If you look at the roller, then if I go to the KR22, you'll notice that the diameter of that roller is updated automatically when we select the KR22 roller to reflect the size, the correct size. Also, all the data should be updated. Now I've got, so that's basically how you select the roller, and it gives you sort of a rundown of the information, the OD, the shaft diameter, the width, and then the static load factor, the dynamic load factor, and whether or not the roller is crowned or barreled. So that's pretty much how you select the roller. I'll turn off the ISO 281 modification factors for now, so I'll just turn those off and just go through what's being printed here. Well, what MechDesigner does is it calculates the equivalent load formula that can be viewed in the help, I think. It also calculates the roller rev count. So this is the number of revolutions that the roller will execute when the cam, or what it will undergo when the cam rotates 360 degrees. And that's very, very important in order to be able to calculate lifetime. And then it displays the estimated lifetime in millions of revolutions, and then which it converts into hours, and finally years. And these two numbers here represent with an operational efficiency of 100%. So it's the years means that it will run at 8,760 hours per year for 689 years. Okay, if you want to enable the ISO 281 modification factors, these you just click the tick box there, and then there are essentially two factors: the reliability factor, the lubrication factor, and the lubrication factor, which is sort of combined with the contamination factor. So in this case, I've selected. Well, let's start off. If I select an L10M, which is the basic, what this is saying is that it gives an indication of the confidence of the lifetime that's been calculated. So this is saying that I have 90% confidence that the lifetime of this particular roller is going to be 7,370 years, which is an awfully long time. So I forgot to change the roller back. So what I'm going to do is just change the roller back to what it was originally, which is the KR16. Okay, there we go, and that reduces the size of the roller and consequently the lifetime. Now, if this was a reliability critical component, and I didn't want this thing to fail, I want to know exactly how long it's going to last, I can improve my confidence level by just selecting, say L, which is the highest confidence level, L 0.05M, and this is a reliability factor of 99.95, so I have a 99.95% confidence that the lifetime achieved will be 37 or 38 years, which is perfectly adequate for my purposes. So the next set of factors here that we've got concerns the lubrication. We can select the type of lubrication. We've got three options. We've got oil filtered inline, oil filtered offline, and these are sort of, you really need to have a look at the standard to check out the definitions of these, and simple grease. And then what we can specify is the type of oil that is being used or grease that is being used to provide the lubrication. And the way this is specified, well, the way we specify it, and you can find this information on the oil specification sheet, is by two temperatures with the viscosity specified at each temperature. So in this case, we've got an oil, these are quite standard, I think. You have an oil temperature of 40 degrees, the viscosity will be 150 millimeters second per squared. And with the oil temperature, when the oil temperature reaches 100 degrees, the viscosity will be 15 millimeters squared per second, which makes sense. As the oil gets hotter, it gets thinner. And then you specify the oil operating temperature that your machine is going to run at, in this case 60 degrees, and what MechDesigner can do then is estimate what the viscosity of the oil will be at that temperature from these two, and from that we'll be able to modify the Hertzian stresses and consequently the lifetime. So for example, if I change this to, I don't know, if I change the operating temperature here and put it up to 80, there should be a corresponding change in lifetime, and there is. So if it goes up to 80, it just dramatically reduced to 5 years. So to put this down to 40, then the lifetime becomes effectively unlimited. The other parameter that you can select in this code, in the ISO 281 code, is you can select the contamination factor, which I understand is the particle size of contaminants in the oil. And this is specified here under ISO 4406 with a code, which the code in this case is -1310. So you can select, there's a whole series of these. And I think the first number after the slash represents the particle size. But these, it's probably best, rather than me waffle on about these in this video, it's best to look in the help under the ISO 4406 code to give a better explanation of what each one of these means. But essentially it's to do with the contamination. And these vary. If I change to oil filtered inline, these will have different codes. And again, for grease, they will have different codes. In fact, grease is simplified in that you just specify high, normal, slight, typical cleanliness. And again, these are defined more clearly in the help. Okay, so we've looked at the roller lifetime. Next, let's have a look at the cam life. So if we click on the cam life tab, then we're presented with some information. at the top here is where we can select the material. Now the way that the ISO standard works for gears is that rather than having a large selection of steels, they categorize the steels, and this is because they've, I guess, experimentally verified various, or in fact 4 separate fatigue curves, or SN curves. So each of these material categories here will obey, or is seen to be obey, a certain fatigue curve. Now at the moment we've got selected a nitro carburized through hardening steel, and it has a quality of ME which is exceptional. There's 3 grades: there's ML, MQ and ME, and in the if I bring over the help file here, might make it a bit clearer. Yeah, the way that you can access this is if you go to the MechDesigner reference help, and then under that there's the dialog boxes, and we're looking at the Cam 2D dialog. So here we go. Where are we? Cam dialog boxes. Dialog CAD line, dialog Cam 2D. So here we go. Here's the Cam 2D, and then it lists the various parameters, various tabs, which are parameters, display, roller life, cam life, and then we're under cam life here. And if we scroll down, we can see if we click on cam life, the cam life tab, then there's a whole lot of information about this, and it takes you through an example, and it talks about the different steel categories that are available, heat treatment and quality, etc. The steel quality, and then finally presents the fatigue curves, the 4 fatigue curves that I was talking about before. So we've got at the moment selected a category 14 exceptional quality material, and if we look at this, there's the numbers here. This gives the range of acceptable hardnesses. If you go outside of these hardnesses, then our understanding is that the data isn't available, and therefore the calculations will be unreliable. So we know that we've got an acceptable quantity. Now we can specify a hardness of between 300 and 650 in this case. Now at the moment we've got specified 475 here. So you can change the hardness to any number that you like, but within these limits. So if we look down here, if we look at the numbers that have been calculated by MechDesigner, then what's calculated is the contact stress, the maximum contact stress. So as the cam rotates around, at some point on the surface of that cam there will be a maximum contact stress, and that's the point at which you would expect fatigue, the most likely point at which you would expect fatigue to occur. And this takes into consideration all the Hertzian stresses, etc. All the Hertz, well, it uses the Hertzian approach to calculate the stresses, and takes into consideration all the curvature factors, etc. And so we have the maximum contact stress, then we have the dynamic contact stress. Now the loads in MechDesigner are calculated kinetostatically, which is an idealized version of the forces. What happens with MechDesigner is the forces are calculated effectively statically, and then all the inertial forces are added in as a static force, and from that you can calculate the joints and forces at each. You can calculate the forces at each joint, cam contact or whatever, or gear contact. So that is a very idealized version of the contact stress, but in reality, of course, there will be some vibrations occurring, and we can factor in those vibrations by using the safety factor. So if I go to the parameters tab here, you see there's a safety factor here. At the moment it's currently set by 1, and what this does is it just multiplies the stresses by a factor of 1 to achieve the dynamic stress. In fact, this is, we could put in 1.3, so we have to make an estimate of what we think the contribution of vibration is going to be, or what we think our safety factor should be. So if we go back to the cam life now, you'll see that the dynamic contact stress is now 1000 megapascals. The basic contact stress, which assumes no vibrations, is about 780 megapascals. Now we've specified each material has an allowable contact stress, which is based on the category and what you've specified for your hardness. At the moment it's 950. And if I look at this curve, we go back to the, if I get to the help again, if I can find it. If I can find it. Yeah, here we go. So if I look at this curve here, let's try and make this a bit bigger. So if we look here, we've got on the x-axis we've got the number of cycles that can be executed, and you can see it increases along the x-axis. So we start at 10 to the 4. Well, 10 to the 4 is what, 10,000, which is not very many cycles, up to 10 to the 10, which is a huge number of cycles. So this is a log-log scale. Now the y value, this value y here, is being calculated here, which is the dynamic stress divided by the allowable stress, and that gives a ratio, and at the moment this number is 1.066. We've got a material which is category 14, and I think that samples this, or uses this SN curve number 4. So if we've got a dynamic allowable stress of 1.066, that means it's about here. So it's going to be about here, which is perhaps not good enough. It's giving us a relatively short lifetime of 14 hours. Well, I don't think that would be satisfactory in many machines. So we've got to think of how we can improve this. Well, I can try improving the hardness. So if I'll go here and I'll put 650 in here, and we see that actually does very little. Let's go back to, there we go. Sorry, I've lost the plot really. Right, here we go. So here's the chart back again. So we can see that we've increased the hardness, but it doesn't really matter, because this, between anything above, well, really it doesn't really matter what you do because of the flatness of this curve here. The ratio is not this ratio 1.066 is not being changed. The allowable contact stress hasn't changed because of the type of material it is. So that achieves nothing. So we can conclude from this that really we've got the wrong material. We need to increase the we need to change the material to something which has got slightly better fatigue resistance. So we can go through. We got something for 300, 400. Well, I'll try a through hardening nitrided steel here. So let's take a, I don't know, medium quality and try that. And still we've got a cam life of 93 hours. So this isn't improving much at all. So let's try something a bit more extreme. We'll go for a nitriding steel with a low quality. And now we're sort of finding ourselves getting into a reasonable lifetime. So I think these the nitriding steels have, if I go to here, go back to identify this curve again, I think these have follow curve 1. So we can see that we've got a dynamic ratio of 0.9, so that's we're about here. So we can see that we're starting to get a reasonable lifetime on these curves now for this material, with this material, 3 years. So this is how this works really. You can select the material, you can select the category of material to try and get the lifetime that you require, and then once you've got the category, then you need to select the exact material that fits into that category, and you should achieve the required lifetime. So that's a very quick rundown of how the cam life is estimated. I would obviously recommend reading this section in the help to try and get a better feel for the gear. It's the gear standard. Remember, this is based on the gear standard. We've adapted the ISO gear standard for lifetimes to cams. The contact mechanics are very, very similar. Either way, that allows you to it gives an approach to giving an estimate for the lifetime that you can expect on the cam. Okay, so I've introduced the cam and roller lifetime estimation using MechDesigner. I think this is quite a sophisticated topic, but if anybody feels that it needs more elaboration or more explanation, don't hesitate to put something in the comments below. We always appreciate it, a little bit of feedback. And I'll leave it there. So thanks very much if you've managed to get all the way to the end of this video. And I'll look forward to presenting a new video fairly soon. Bye.